The next speaker is Mr. Saurabh Bhardwaj, who is actually an expert in the climate science in the TERI, and he's also the area convener of our the center. He has over 10 years of work experience in the atmospheric sciences, meteorology, climate science, modeling, training, etc. So he's the best person to speak to you about the climate science aspect of vulnerability assessment and how do we plan for addressing the challenges. Over to you, Saurabh.
Good afternoon, everyone. You heard the earlier two speakers talking about monitoring and evaluation, adaptation. My slides are adapting to what? Monitoring of what? What actions? Why do we need those actions? So ideally, this is why. So I'll try to bring in the whole concept of climate change in front of you and what lies in front of us. Why do we even need to care about it? Why do we need to adapt? To what we need to adapt? I think so. Not most, all of us are being affected by the changing climate. When you all were small, were young, at the time you were kids, and now you yourself has seen climate changing, right? Now the science provides you the power to also see in what manner these changes would go in next 5, 10, 15, 20, 100 years in future. My objective is primarily to give you a perspective of how we do that. And we have the capacity to do that. We are also assisting the Department of Science, Technology and Environment to generate such products, to mainstream scientific knowledge into development policy planning. Because without mainstreaming these two, our policies will not have those futuristic outlook and science involved that it really needs at this point of the hour. So, first of all, I'd like to thank the organizers for calling me here for this very important workshop. Keeping things short, if we all know about climate change, the main difference, what I tell about climate change to people is, there is one thing called as a weather, which is day-to-day changes. It's sunny today, it's cloudy tomorrow, it's rainy day after tomorrow. So climate is not changing, it's weather that's changing. But if you see, and the example that I took, that what kind of summers or what kind of winters or what kind of monsoons were there when you were a kid, and 30 years hence, if you see a change in that, a long-term change, then you can very well say, yes, the climate has changed. So it's a long-term average, changes in the long-term average. That's how climate changes are all about. But more than that, it is also pertinent to understand that such kind of changes have been happening since many, many years in the past. So what is changing these days is the variability of that climate. The variability that climate used to have is now changing at all. Totally it has changed. Now you have, probably your monsoons are, the total amount of rainfall remains the same. But when it rains, it just rains for 5 days. The entire season, rainfall rains for just 5 days. So you have more number of drier days and more number of heavy rainfall days simultaneously occurring in one season. That's what climate change is all about. It's the variability that is changing with time. And this is what the kind of perspective I would like to bring in front of you, because we can learn about climate change from many different papers, from many different textbooks. But if you really need to plan, we need to plan for these kind of variability changes so that our sectoral plans are robust to prepare themselves to such kind of changes in the future as well, right? So what do we use? We use set of equations called as those scientific equations, physical equations, that are basically representing all these interactions that are happening around you. So it's a climate system in front of you. This is what is happening around us. If I represent everything in a set of equations and try to simulate it for the entire globe, that's a model, that's our global model. And if I want to know that for my area of work or where I stay, I need to downscale it. That's called as a regional model. So from global models to regional models, we get regional level data that if my climate is changing globally, I have been hearing about global warming, if global warming is happening, what does it mean to me? So I need to downscale that stuff. When I downscale, I use another set of tools which we have used for Puducherry as well, called as regional models. And then I know that if there is a 2-degree warming in future, if there is a 1.5-degree warming in future in next 30 years or 50 years, what does it mean to my city? What does it mean to my business? What does it mean to my policies? That is why it is very important. Now in front of you, on your left, is the temperature reconstruction for the last 2000 years. And if you see the last 1850 to 2020 graph, you know, the observed where it is written, that's how our Earth has warmed in the last 200 years as compared to the last 2000 years. We have never been this warm with humans living. We have been warm in our earlier centuries, but have never been this abnormally warm in such a quick time. And on your right, the climate models basically tells you that this warming that you are seeing now is actually due to human-induced factors. And on your right, the graph is basically tells you by modeling that if you include human factors, you see the red band over there, the models simulate the same temperature rise as is seen by the observations. But if you take out the human factor and let the models simulate the warming as it has happened by natural variability, by natural causes, the blue plot is what you get. It doesn't simulate your observations well. And this attributes the warming that you are seeing right now to human-induced factors. And this has been actually presented in the, I've taken it from IPCC latest report AR6. And on your left, the kind of black bar that you see, it's 1.1 degree warming that we have already seen. Earth has warmed 1.1 degree already, and you can see what is happening around the world. There is flooding happening at some places, there are droughts happening at other places. In India, we already know our coastlines are bombarded each year by severe storms, floods in urban scale sectors. That's what 1.1 degree has done globally. Global average has been 1.1. And on your right are the different factors that have contributed to this warming. And primarily these factors are the GHG, greenhouse gas emissions, that the world has been doing, and what kind of emissions is on the further on the rightmost graph. And most of these emissions are due to the human man-made factors that we have. So that was a context of climate change, that we all are agreeable, yes, there's something wrong that is happening. Now, of course, there are evidences towards it. One of the very basic evidence that very long back that we know of is the Gangotri glacial retreats, the glacier retreat and losses, the whole Hindu Kush Himalayan region. Most of our glaciers are retreating and they are losing out on their mass. And this is basically resulting in a lot of loss of livelihoods to the mountain community. We are down south here. We are an urban center. What have been seen also is the flooding incidences. You see Bihar, you see in Kerala, specifically even in Chennai, when the Adyar River flood was there. Due to increased urbanization, we have been losing our wetlands, we have been losing our flood buffers, and that has actually resulted in most of our city and urban infrastructure getting affected year after year. Because you remember I mentioned about climate variability is changing. Now you get more rainfall in lesser amount of days, and this is what is in store in front of us. So the headlines, if I may say, and specifically for India, 13 out of the 15 warmest years since 1901 have just come in the past 15 years already, right? And this is purely by the observations that we have in front of us. And the models are also showing a very bleak picture for the future. Now this is what the India have been in last 2 months. Our March has been the warmest in the last 122 years. And our April have been the warmest in the last 72 years, right? Now, I'm not saying this is basically due to climate change, no. What I'm saying is we can expect this year after year in future. So are we prepared for this? Are we prepared for such kind of extremes changes in the future? That is exactly why you need to mainstream such data sets in your policy scenario or your policy planning on your developmental policies. I'll skip this and I'll directly come to what lies in store for Puducherry, okay? Right, so what we did for Puducherry, we used Indian Met Department data set and also to see the observations in the past, and for future we use the NASA data at 0.25 degree resolution, which is 25 by 25 kilometer resolution of 21 models, and presented the data in 2 different scenarios in future. Scenarios means, all right, we know something is wrong. In future, it's warming. What if we try to do more mitigation? What if we try to limit our emissions? Of course, you will have a lesser warming. So there's a scenario for that. And if you don't do anything, if the business as usual happens, there is a different scenario for that. So we have presented a kind of information that if the whole world does not warm that much or it warms very high without any mitigation scenarios, then we have a higher warming scenario. But if we do a very extensive and aggressive mitigation policy actions, the warming would be lesser, so you have a medium warming scenario, right? So we presented such kind of scenario level studies for Puducherry. But for the past data set, we also understood, and DST have also done, Balaji has done few of the past studies, and there is a standee over there as well. What we have also added in this is the extreme level analysis that has put into it. So particularly on your left are the 4 regions of the Union Territory, and you clearly see the last 30 years, and when I say last 30 years, that's the last climate cycle. 30-year average of weather is 1 climate cycle, minimum 30 years. There have been considerable warming that Puducherry UT has been seeing. But particularly if you see, all right, there is warming, let's talk about very hot days. Has that been increasing? So how we understand very hot days is, we set up a threshold. A 95th percent threshold or a 99% threshold means a day which has more than 37 degrees, 38 degrees, considerable temperature. How that has changed in the past. And such kind of days have also increased for our UT. And then also seeing cold nights. Cold nights is a factor. When the nights are also warm, it basically reduces your comfortability. It also affects your plant growth and plant health. So the temperature difference between the day and the night also needs to be maintained for proper human comfort as well as animal as well as plant health. That is also changing. The minimum temperature is decreasing. The rise in minimum temperature is much higher as compared to the maximum temperature rise. So your night-time temperature is also increasing. Let's see about the future. We understood annually as well as seasonally which seasons are getting warmer. So in front of you, what you see is the annual graph, and then you see 2 separate lines. These are 2 different scenarios that I was talking about. If your mitigation is good, your warming is lesser, but you still have warming. But if you do business as usual, what you are doing right now, how much of warming is expected? So in future also, your maximum temperature and minimum temperatures will continue to rise seasonally over all UT regions. And specifically, your minimum temperature changes, and minimum temperature is much higher for the UT regions and maximum temperature, meaning the relative changes, both are increasing for the future. And talking about the extremes, well, there is also a sad part here that even the extremes that you have been seeing in the past will continue to act in the future as well over our Puducherry region, UT region. When we talk of rainfall, now rainfall is a very peculiar parameter. Unlike temperature, regional rainfall does not have a very strong trend. You cannot say that rainfall has been increasing or rainfall has been decreasing, because it's highly variable. One year is very high, other year is low. So if you do the average, there is no change at all. But what is important is to see whether is there a change in the extremes. And yes, for Puducherry, such kind of changes in extremes have been seen in the past data set. Specifically, for Karaikal and Mahe, the days where these extreme rainfalls are occurring have been increasing in the past 30 years. And in the future, and this is towards the end of my slides, the future also shows such kind of extreme behavior to increase in both the scenario. Now the bottom line out here is that we know our past, we have the data for the future, we know seasonally how the changes are being done. How do we incorporate this data in our adaptation and mitigation plans? And this is where the SAPCC revisions, the SAPCC documents, they come into picture. They mainstream such kind of data, do an adaptation recommendations, mitigation action plans, and then bring forth the advisories to different sectors that how these policies should be changing in the future. Particularly to tropical cyclones, there is not much data that we have for the future, but what has been seen in the past is the number of cyclones have not changed much, but the intensity of those cyclones have changed. Whatever that occurs in the Bay of Bengal now is very fierce, and that's because the sea surface temperature now is very high as compared to 30 years back. So whenever a cyclone is occurring, it is category 5 or category 4 cyclone over Bay of Bengal. And in future, what the models projections show globally and also over Indian Ocean region, that this kind of analysis, this kind of understanding would remain. Tropical cyclones will not occur very frequently over this area, Bay of Bengal, but it would be much more fiercer. In Arabian Sea, yes, the frequency would be changing. There will be more cyclones occurring over Arabian Sea because Arabian Sea is now rising at a much, the Arabian Sea warming has been much higher than the Bay of Bengal warming. And this is how we basically help the policymakers, stakeholders, academicians by devising such tools. So this is a climate atlas or a climate services TERI climate tool where you can, sitting on your system, basically select your area and can see such kind of information at your desktop. And particularly if you want to design something for flood management, and my colleague would be talking much more on this tomorrow, we have devised a flood early warning system which actually gives you another set of a preparation tool to be aware of such impending floods on your city 72 hours earlier or 1 or 2 days earlier. So such kind of tools, such kind of mainstreaming of the knowledge in your development action planning is what has helped many cities in the past and is what have been recommended over all the urban centers over India as well. Thank you so much.
The likely impacts of climate change in Puducherry, and he has very graphically presented the scenarios for you. But the end of it, the gist of what he was trying to convey is that when you really want to strengthen the capacity of the communities and the stakeholders, you need to give them some climate science monitoring tools. So it's important
and then TERI has worked in this area. There are other institutions. IMD is the national institution which is working in this area. They are trying to give you tools for providing this information to the communities in time, so that there are early warning systems, signals, data collection and data provision technologies. It is important that you build this into your response system and your action plans. Thank you very much.